All right, let's talk about one of the most explosive risks in software today. We're diving into the new number 3 on the OWASP top 10 list, software supply chain failures. And look, this is way bigger than just using a component with a known vulnerability. We're talking about attackers getting inside our digital factories and poisoning the well right from the very beginning.
So let me just ask you this. What if the very tools you rely on every single day, the libraries, the frameworks, your build pipelines, what if they're actually your single biggest threat? That is the absolute heart of the supply chain problem. Attackers aren't just trying to pick the lock on the front door anymore. Oh no, they figured out how to get a job on the assembly line, tampering with the products before they even roll out. To really get our heads around this, we have to accept that the battlefield has completely changed. The software development lifecycle, the process we always thought of as our safe internal workspace, is now a primary target for attacks that have just massive, cascading consequences. So when we use this term, software supply chain, what do we really mean? Well, simply put, it's everything. It's all the ingredients that go into your final application. We're talking about open source dependencies, your build tools, the CI/CD pipelines that automate everything, the registries that store your code, and even the update mechanisms. That digital factory analogy, it's perfect. It's the entire assembly line, from raw materials to final delivery. Now, what's absolutely staggering is how fast this risk is shot up the charts, landing at number 3 on the 2025 OWASP list. But here's the real kicker. In the survey that helps create this list, a full 50% of security pros called this their number 1 risk. That's the highest consensus for any category. It tells you exactly what's keeping people up at night. And this isn't just a feeling, The data is screaming it. We've seen a 156% year-over-year jump in malicious packages being uploaded to public code repositories. This isn't some slow-moving trend, it's a flat-out explosion. The open-source world we all rely on is becoming a minefield. So to really appreciate the danger here, we've got to dissect these attacks. How exactly does the chain break? Let's walk through a couple of real-world scenarios that show just how scary and immediate this threat really is. Okay, one of the most common and frankly devastating ways in is the maintainer account takeover. See, instead of trying to find a clever bug in the code, attackers just target the people who write it. They'll use some really sophisticated phishing to trick a trusted developer on a popular project into handing over their login credentials. The compromise of packages like Chalk and Debug is a perfect, terrifying example of the speed and scale we're dealing with. An attacker sends a convincing phishing email, they steal the developer's keys to the kingdom, and then they push out malicious versions of over a dozen popular libraries. The craziest part? The whole thing took less than 4 hours. 4 hours from one email to compromising packages with over 2 billion weekly downloads. The blast radius is it's almost impossible to comprehend. All right, next up we have an attack that is so simple, it's almost beautiful in its evil genius. It's called dependency confusion. This one exploits a simple default behavior in most package managers, which is that they often check public sources before your private ones. Here's how it works. An attacker finds out the name of a private, internal package you use. Then they go and publish a malicious package with the exact same name to a public library, but they give it a higher version number. So what happens? Your automated build system sees this newer version out in the wild and thinks, oh, an upgrade. It helpfully pulls it down and runs the attacker's code right inside your trusted network. So simple, but absolutely devastating. And just when you think it can't get any worse, it gets automated. In 2025, we saw the rise of the Shai-Hulud worm. This was the first successful worm that could spread itself through the NPM ecosystem. It didn't just infect one thing. No, its malicious code would steal a developer's security tokens and then use those tokens to automatically push compromised versions of any other packages that developer had access to. It's a threat that literally spreads itself, growing exponentially all on its own. And here's the most important part to remember. A supply chain breach is almost never the end game. It's just the beginning. It's the front door attackers use to steal data, to move sideways into your cloud environment, or even to deploy ransomware. And because the bad code is hiding inside what looks like a legitimate signed piece of software, it can sit there for months, totally undetected, giving attackers all the time in the world. Okay, that was a lot, and it's definitely alarming. But now we're going to pivot. We're moving from the problem to the solution, because the good news is we can defend our digital factories.
And the absolute first step, the foundation for everything else, is visibility, because you just can't protect what you can't see.
This is where the SBOM, the software bill of materials, becomes your new best friend. Just think of it like an ingredients list for your software. It's a simple file that lists out every single component, every library, every dependency, even the dependencies of your dependencies that make up your application. So when the next big vulnerability hits, an SBOM lets you instantly answer the question, are we affected, instead of scrambling for weeks.
Now you're going to hear about two main standards for SBOMs. There's SPDX, which is really comprehensive and great for things like license compliance, and then there's CycloneDX, which is a bit more lightweight and was built from the ground up with security and vulnerability management in mind. Honestly, they're both great. The one you choose just depends on what you need to do.
And here's the best part. You are not expected to create these things by hand. This whole process is automated by tools called Software Composition Analysis, or SCA tools. They plug right into your development pipeline, automatically find all your dependencies, generate that SBOM for you, and then continuously scan for new vulnerabilities. So once you have that visibility, once you can see everything, the next logical step is to start hardening the weak spots. It's time to reinforce the walls of your digital factory, especially in the areas where attackers are hitting the hardest. Your CI/CD pipeline is pretty much ground zero for these attacks, which means locking it down is not optional. We're talking about the basics, like enforcing multi-factor authentication everywhere and applying the principle of least privilege, so even if one thing gets popped, the damage is contained. The goal here is to build a trusted, verifiable path from a developer's keyboard all the way to production.
And it's the exact same story for your artifact registries and your update process. Instead of letting developers just pull random packages directly from the internet, you should be using a curated internal mirror that acts as a secure checkpoint. It gives you a place to scan and approve things, and you should absolutely be requiring digital signatures on everything to prove it hasn't been tampered with before it gets deployed.
Okay, we have covered a ton of ground, so let's boil it all down into one final memorable action plan that you can start thinking about today.
Here are the 5 most critical actions. 1. Start generating and maintaining SBOMs for all of your apps. 2. Integrate that automated SCA scanning right into your CI pipeline so it runs on every build. 3. Harden your critical systems, your repos, your pipelines with MFA and least privilege. 4. Actively monitor your supply chain for weird or suspicious activity. And finally, number 5, have a plan. Don't ask if one of your dependencies will be compromised. Prepare for when it happens.
I want to leave you with this thought, because it really gets to the core of why this risk is so high on the OWASP list. The impact is exponential. A single compromised developer account, a single malicious package, it can set off a catastrophic chain reaction that hits thousands of organizations all at the exact same time.
So, the bottom line is this. Your software supply chain is the new front line in cybersecurity. The question you need to be asking yourself isn't just, are my applications secure? It's, is the very process I use to build them defensible? So, are you prepared?